I'd like each person to understand that humans are really complex organisms and that big data and systems biology are necessary to interpret this individual complexity, and the analysis of your data with this approach will lead to optimizing actionable possibilities that you can use to optimize your wellness and prevent disease. And the really important take-home point is, look, you are the master of your health. It's up to you to educate yourself so you understand these things.
Leroy, or Lee Hood, is one of the architects of modern biology. He invented instruments that turned DNA into data, and then argued that biology must be read as a system, not as a set of parts. Across 8 paradigm shifts, he moved medicine from craft to an information science. In this conversation, he traces the arc and stakes a claim of P4 medicine: predictive, preventative, personalized, and participatory. And he would say that these are ready in principle, but its hardest frontier is persuasion. Listen now for the 3 gifts that Lee gives us: systems vocabulary for health, concrete demonstrations that early detection and actionable possibilities work, and a strategic insistence that changing institutions and civic life is part of the experiment. Off camera, we push these lessons into politics and economics, and over the coming weeks, we will publish a print companion for episode 100 in the downstream series that translates this topic into pilots, policy, and practice. Hear this as an invitation. Understand the system, activate your agency, and help conduct the symphony of our health.
Dr. Leroy, or better known as Lee Hood, MD, PhD, is one of the great scientific pioneers of our time, known as the father of systems biology and co-inventor of the automated DNA sequencer. He has helped transform modern medicine by linking biology to information science. Through groundbreaking innovations at Caltech, the Institute of Systems Biology, and now Phenome Health, he has advanced the concept of scientific wellness, a model that is predictive, preventative, personalized, and participatory. Dr. Hood's influence spans decades of discovery and entrepreneurship, from co-founding Amgen to advising governments of healthcare reform. His mission is clear: to revolutionize medicine by shifting the focus from reactive treatment to proactive health optimization. And on the DNA of things, Dr. Hood's story perfectly embodies the podcast mission to explore how innovation, biology, and narrative intertwine to shape the future. And his journey will offer listeners today not just a history of discovery, but a vision for human flourishing. Dr. Lee Hood, thank you so much for taking the time to speak with me today.
It's a pleasure to be here.
Now, we were just talking before we got underway, and clearly, I'm sure as far as listeners are concerned, but certainly myself, your reputation precedes you. Actually, if I think back to my very first podcast, I believe it was with your understudy, Dr. Nathan Price, your co-author, actually, as you know, on the age of scientific wellness. And it's been a wonderful journey on the DNA of things. And I told myself when I started, I don't exactly know what this is, but I'm sure I will know it around episode 100. And we're on our way to that. So it's a really beautiful full circle that has unfolded here. And, so to get into our discussion today, I'd love to, learn more about the, man behind the mission, all of these experiences. And I'm just scratching the surface in terms of sharing what I understand, from the advent of DNA sequencing to systems biology itself, and this notion of the 4 Ps in terms of the age of scientific wellness and what you're working on at Phenome Health. This is the pinnacle or the frontier of what you've developed over time. I wonder if you can share, as far back as you would like, how something so revolutionary comes into being.
Sure, I'd be glad to talk about my perceptions anyway. I think the journey on dealing with human complexity, which is enormous, began when I started in 1970 at Caltech as an assistant professor. And like all assistant professors, I looked ahead and said, okay, what are the big ideas I can really attack? And in thinking about what my intrinsic interests had always been, it was understanding the complexity of human organisms. And in that context, it was clear to me that there were several things that were missing in 1970. So one, dealing with human complexity really, in my view, could only be dealt with by big data. And at that time, there were absolutely no technologies for generating big data on individuals or on biological specimens and so forth. And the second issue was, suppose you could generate the big data, what would you do with it? And that was the emergence of thinking about what later became systems biology, which we'll talk about in a few minutes. But these two thoughts set me off on my assistant professor career with two major projects. One, a project I'd done since my graduate days in molecular immunology, and that was the essence of trying to decipher biological complexity. How was it that antibodies had the ability to interrogate the entire world of foreign antigens and protect people against it? That was the essence of the question I was trying to answer. And it led to absolutely fascinating experiments that deciphered the complexity of antibody diversity. The second area I decided to do, which was new for me, was to establish in my lab a cross-disciplinary set of scientists that could begin to develop the technologies that would lead us to big data and later to what came to be systems biology. So I set off on this juncture, and it was absolutely fascinating in retrospect. In looking back, it took me through what I'll call 8 different paradigm changes. And each advanced our understanding of the complexity of biology. But what they irrevocably did was lead to data-driven health, a new approach to healthcare, which we'll talk about in a few moments. So the journey was not without challenge, as any big new ideas are. And what was interesting was at Caltech, there was a real antipathy of the senior faculty in my division, biology, against technology. And they argued I should be shifted into engineering. And we had a battle over that. And in the end, I won and I stayed in biology. But what I was able to do over a period of some 30 years was develop 6 different instruments that allowed me to read and write DNA in various ways. And the two most significant in terms of paradigm changes were an automated protein sequencer, which could determine the order of subunits in a protein, using 200-fold less protein than had ever been required before. So it gave us access to a whole series of important biological molecules that had been unprobable. And actually, I remember one issue of Science where we had 4 different articles using that whole approach to define the molecular features of new systems dealing with small amounts of protein. And of course, the instrument that, in my view, was the most important of all was the automated DNA sequencer. So the first paradigm change, in a sense, was bringing engineering to biology and beginning to give it the tools that really transform biology into what I came to call an informational science. The second paradigm change was enabled by the fact we'd invented the automated DNA sequencer, where I was invited to, in the spring of 1985, the first meeting ever held on the Human Genome Project. 12 of us debated about the pros and cons of the project and came to two really striking conclusions. One was that it was feasible, although at that time really difficult to imagine how we were going to do it. But two was we were split 6-6 on whether it was a good idea. Those opposed were fearful that big science in the form of the Genome Project would eliminate funding for small science. And of course, exactly the inverse happened. The Genome Project enriched all of small science in hundreds of ways we could talk about. But what it meant is when we went out into the world, 80% of the biologists in the beginning were utterly opposed to the Genome Project. And I had some of my most hostile lectures I can ever remember in my career in the early stages of the Genome Project. But of course, it was enabled and it was artfully done in a political sense, which we can talk about if that is of interest. But it started in 1990 and finished in 2003. It was a $3 billion project, and we did indeed decipher the human genome. And this generated enormous amount of hype that was absolutely untold about every protein being a drug and nonsense like that. But what it did is it set the framework for understanding the essence of human complexity, because the genome is the software for all that we are, and we'll talk more about that at a little bit later time. I actually went to biology with an idea. One of the objections the biologists had to my lab is it was very large because I had all these different kinds of scientists, engineers and physicists and astronomers and computer scientists and chemists. And I said, well, one way we can make my lab smaller is if you let me start a new department that is applied biology, where we'll have each faculty member be a different specialty, and that faculty together can invent the technologies that are going to decipher human complexity. And all of the other 5 divisions in Caltech thought that was a great idea. Biology vetoed it. Obviously, it didn't want to have a competitor within department. So it was possible for me to move to the University of Washington in 1992 and start the first cross-disciplinary department of molecular biotechnology at the University of Washington Medical School. And we started the Department of Molecular Biotechnology, and it was absolutely striking in how effective this department was. One, Phil Green wrote the key 2 software pieces for the whole Genome Project, namely how you assemble DNA and how you assess the quality of DNA sequence. Rudy Ebersol and John Yates absolutely pioneered human proteomics, and they had the first 2 major techniques that kicked this whole field off. And they went on to be leaders for the rest of their career in that area. And we developed actually the use of inkjet technology for very rapid synthesis of DNA. And it's an approach that Agilent still uses today. And I'll tell you how we're going to use it when we talk about the 8th paradigm change and so forth. So the cross-disciplinary department idea was the 3rd big paradigm change. And what happened during the 8 years I was at the University of Washington is it absolutely became obvious that the idea of systems biology was too far away from classical views of biology. And in 10 ways I won't go into and describe, I got blocks thrown in front of me with regard to biology. I remember when I went to the head of computing at the University of Washington, he pointed to a small janitor's room and said, that's all the space a biologist would ever need for computing. And, they didn't understand that systems biology was going to usher in the era of informational biology and big data and enormous amounts of information. And that was what led me in 2000 to resign from the University of Washington to start the Institute for Systems Biology, the first ever systems biology department in the world, and to really begin pioneering with this systems approach, which basically was to say, look, if we're to understand a complex organism like a human being, it's exactly like understanding a car. You have to know what all the parts are. You have to know what they're connected. You have to know what the connected parts do and how they globally permit the car to actually run. And in an analogous way, you have to define a parts list for human beings and the system you're looking at. And then you have to connect it together in the biological networks that underpin normal physiology and disease and so forth. And this is exactly what we did with a very simple system, the use of galactose in yeast. And we showed how you could define all of those properties by dynamically changing networks in yeast that explained the metabolism beautifully. And we did exactly the same for the scrapie disease in mice, a disease that we could induce at will, and then look in the brain at how all the networks changed. And we were able to delineate 4 categories of networks that successively were activated in the 2-month course of this disease that explained all of the pathophysiology of the disease completely. So it was 2 really monumental things saying systems biology is going to fundamentally give us the means to take big data and translate it into biological information and so forth. With this, in 2002 or 3, I then started thinking about healthcare and where we should go there, and formulated the idea of P4 healthcare, a healthcare that should be predictive, preventive, personalized, and participatory. And of course, what's turned out to be is the first 3 P's, prediction, prevention, and personalization, are all scientific, and we know how to manage that now. But the 4th P, how do you persuade people to accept a new healthcare, that is patients, physicians, healthcare leaders, healthcare technologists, and ultimately the people that adjudicate the profession and politicians that pay for it. Enormous challenge in persuasion. And this is the one big unsolved problem that we can return to if we care to later. But the next paradigm change was really an interesting one. P4 medicine gave us absolute key insights into strategies and technologies that we could use to approach human complexity. And I put a series of grants into NIH and always got the same answer back. This is too advanced. You haven't proven you can do it, on and on and on. So I decided to go out, and actually to 4 different countries, I went and said, look, I'll start systems biology for you in this country if you'll give us money to study P4 medicine. And I got very far in all 4 of them, but in all 4 cases, various things intervened. And again, that's a great story in itself. But the 5th one I went to, a friend of mine in PricewaterhouseCoopers said that Luxembourg had a minister of economy that was really driving the whole government, and he was really interested in biotechnology. And he hooked me up with him, and I talked to him for a half hour. And at the end, he said, well, you've convinced me, write me a proposal for how you can bring systems biology here and advanced technology and everything. And I remember saying, well, what are the boundary conditions for this grant? And he said, oh, ask for what you need. So we asked for 100 million over 5 years. And we started an institute there. And that 100 million enabled us to solve the technologies and strategies of P4 technology. So in 1913, I was able to actually go and propose to 108 of my friends that they submit to a genome and phenome analysis over a period of a year. So doing the whole genome and then analyzing the phenome in ways we'll talk about in just a few moments at 3 times across the year. And I remember going to Francis Collins, who was a good friend of mine at NIH, and saying, look, I have this new idea about human health. I'd really like to have this data-driven approach, and we'd like to get some support to get this started. And I remember Francis saying to me, Lee, the role of NIH is to study disease. It's not to study health. And, I snipped, well, I guess it's misnamed then, isn't it? And anyway, I went back and we used philanthropy to get the project started. It was successful. And then we started a for-profit wellness company called Airvale that gathered over 4 years, 5,000 clients. And it was enormously successful on the scientific side. It wasn't successful on the economic side, but it gave us an enormous amount of data from which we've derived almost 30 papers now and different views of what scientific wellness is across the entire spectrum of humans, because the people in the study range from 21 to 93. And we'll talk a little bit more about that later. But the next big advance for me, so data-driven health was kind of part 6. And then part 7 was when I was invited to go to Providence, which was a healthcare system with 51 hospitals in Western states to bring wellness and prevention. And I came to understand the enormous complexities in dealing with healthcare organizations in terms of leadership and in terms of physicians and their willingness to accept new kinds of ideas. And we did a few kind of minor important things, but after 4 years or so, I resigned to start Phenome Health. And this was a new nonprofit that was dedicated to advancing the whole idea of data-driven health. And the big push was to extend the Human Genome Project now to the Human Phenome Project, with 1 million people analyzed over a 10-year period, because that would validate both improvement in healthcare, cost savings, and it would drive the technologies that would bring the cost of phenomics down. And in the midst of all of this, we were getting enormous amounts of data on humans with absolutely fascinating drug targets and so forth. And of course, getting pharma interested in wellness and prevention was a bit of a challenge, at least in the beginning. I think it's beginning to soften up now. But the 8th paradigm change was the idea that we would start a company called P4 Bios that would actually create peptide drugs that could be used in brand new ways to be able to really effectively generate drugs for wellness prevention and disease as well. We're just in the beginning stages of starting to raise money for a company that I think is going to, in 10 to 15 years, absolutely change the paradigms of drug discovery in pharma. And we can talk about that if we have time at the end. But the point I'd like to make from all of these paradigm changes And what I learned was in 7 out of 8 cases in the paradigm changes, it was very small organizations that actually catalyzed the undertaking. And the importance of spinning off these organizations, and they can be for-profit. And Applied Biosystems was a for-profit that developed the first 4 tools and actually transformed biology that we developed. Or they can be not for profit, like Phenome Health is, that's really pushing the idea. And I developed about 9 of these small agile companies that facilitated in all of the paradigm changes except for the genome. And that was a big collective integration of many points of view from different people that came together and work. So if you want to change the world, do it with small, agile organizations, I think is the big key. That's how I started too. It's very hard for big organizations to initiate paradigm changes because they're too embedded in the past to see the future. So anyway, so that brought me up to, the point where we are today, and we can go in and talk about things. So be glad to answer any questions you might have.
Amazing. Yeah. So I just want to make sure that for the benefit of the listeners and for myself, I've captured the 8 paradigms here. And so I think it was, something like number 1, bringing engineering to biology. Number 2, the automation of DNA sequencing.
No, number 2 was the Genome Project.
Right. So which was facilitated by the.
And then number 3 is cross-disciplinary.
Cross-discipline.
And then number 4 was systems biology.
Mm-hmm.
And then number 5 was the vision of P4 healthcare.
Mm-hmm.
Then number 6 was this data-driven initiative with 108 pioneers in Airvale. And then 7 was the idea we could have data-driven health. And our major project should be the 1 million-person project, an extension of the Genome Project. And we're bringing that to the Trump administration as we talk, trying to persuade RFK that the wellness and prevention he wants is exactly what we have now.
Mm-hmm. Mm-hmm.
We'll see how that goes. And then the last one, the 8th one, was the idea of peptide drugs.
Peptide drugs. Okay. And all of this facilitated by these small, scrappy, agile companies.
Except for the Genome Project. Yeah.
Except for the Genome Project, yeah. Which, is interesting in and of itself, because there were those kind of, I don't know if you call it co-opetition of the NIH funded project and the, what was it? The Craig Ventnor funded project, which of course, leveraged all the open source insights through the shotgun sequencing approach. Of course, that wouldn't have existed without the other, and maybe it wouldn't have gone so fast without the injection of that new technology. It's really funny to hear you go through some of these technologies, which frankly just made my own academic and professional career possible. So I think about, well, just even as far back in my undergrad and my honors thesis project, it was very much, yeast genomics. I actually was, they leveraged those yeast robots. We had one of those centers in Toronto, like the double knockout systems, and right, yeah. And my project was actually a little bit more mechanistic. I was studying the yeast Saccharomyces cerevisiae 2-micron specifically, as this, apparent selfish DNA thing. Why was it there? It didn't seem to be conferring any selective advantage on the host. And so I got to play with all of these, tools of molecular biology and proteomics. Before too long, obviously, seemingly sealing my path, the selfish DNA path, because that kind of, attracted the attention or connection of Ford Doolittle. And a lot of his work was, testing, proving Lynn Margulis's endosymbiotic theory hypotheses, leveraging the old sequencing technologies. But by the time I came to Ford's lab, it was very much, the new sequencing technology. So I finished my undergrad right at around the time the genome project was finishing. And so I got to, play in the space of metagenomics. So this was actually sequencing environmental samples and using all of these bioinformatic tools that it seems, your vision had pioneered to, effectively work with Ford to, reconstruct Darwin's tree of life through understanding processes like lateral gene transfer and, the adaptation of these more opportunistic invasive bacteria. So whether they be pathogens or force to be reckoned with in bioremediation, or drug resistance. And then that led me to the gut microbiome, where I worked with Jeffrey Gordon's understudy, Ruth Lay, to do the first case study of how the infant gut was colonized, and in collaboration with Twins UK and King's College London, the first studies that looked at the gut microbiome and in the human genome through looking at these twin pairs over time. And so now here I am speaking to you, and you've got Arival, and you've got this bigger project initiative around Phenome Health and looking at that relationship over time. And it's just absolutely amazing. And it actually speaks to something that I learned about myself, as an academic in the undergrad, as I suddenly got very good at, math and science once I understood the human plunge behind it. That's when it became really fun to read about the experimenters and, like on our side of the border, like, Banton and Best and the cure for diabetes. And so to hear this kind of 8-part paradigm shift is really amazing, that it's really happening in real time. And we're here on the frontier, and, there are all these things coming together insofar as, what you're doing with Phenome Health. And one of the things that I noticed in the funding that you secured, which I think was around 53 million in collaboration with the Buck, was that?
Yeah, it was ARPA-H funding. Yeah.
Right, the ARPA-H funding. And one of the things that I saw there is, besides everything that you talked about, is like applying the benefits of these 8 paradigms, over time in this vision and addressing that 4th P, participatory. One of the things that stuck out to me was, your mission to pull in, multiple cohorts, multiple, groups of study. And so like the Arival was like the proof of concept that yes, indeed, this is something worth doing at the level of, I think, was it thousands?
5,000.
5,000, right? And so, of course, you see projects like the All Bus project. So you've got like the million genomes, and then you've had initiatives like, say, 23andMe, and then you've got other publicly available biobanks. So how does that work insofar as taking what you've proven with Arival and attracting others to come in and play with Phenome Health? I assume that's a part of what you're doing. So what does that playground look like?
Well, let me, for the reader, just make some simplifying assumptions and then talk about the major points that came out of Arival that we're applying Phenome Health to, okay?
Okay.
So the idea of data-driven health is the idea that we do your genome, and your genome essentially gives you the range of potential of your health trajectories. What actually determines how you go from birth to death and how your phenome changes are 2 things that really influence it. 1, your behavior, and 2, your environment. And we can measure those things, called the phenome, by looking at blood analytes, by looking at digital health devices like Fitbits and Oura Rings, or by looking at the gut microbiome and so forth. So we can make thousands of measurements that give us insights into fundamentally what you are. And that's exactly what we did in Arival with the 5,000. And what came from those studies are a series of actionable possibilities. And an actionable possibility is something that comes from your data that, if you carry out, will improve your wellness or let you avoid disease. And I'll give you an example. I had really low vitamin D. And when I started taking 1,000 international units, the typical dose didn't touch it. And it turned out my genome had two variants that blocked the uptake of vitamin D. And the only way I could get my vitamin D up to normal levels, and it's important to have normal levels of vitamin D, is to take 15,000 international units, which would be toxic for many people. So, and I maintain at 5,000. So data-driven health gave me the actionable possibility of how I do deal with a genetic deficiency. And there were hundreds of these that came out of Airvale that were unique to different individuals, quite obviously. When we analyzed in more detail with these 25 to 30 papers we've done now, each taking a different glimpse, we've shown that the genome has probably 8 different categories of actionable possibilities that together sum up to more than 10,000. And they're almost not used at all, which I think is a real crime. We showed that we could take your blood analyte data and we could, using systems biology, identify networks and communities, and we could distinguish between normal and disease ones. And that gave us ideas about actionable possibilities and about drug targets with that. And the other thing that we've done that's really striking is we can do 5 health trajectories now for each individual. One is that determine your biological age, the age your biology says you are. The lower your age is relative to your chronologic age, the better you're aging. And what we showed in the Airvale program is that the average person lost 1.5 years of biological age per year they stayed in the program. And one of the interesting questions is how far down you can actually drive this. We don't know. But biological age is an enormously good assessment of how well you're aging, and it's one health trajectory. A second is we can do a biological BMI that uses your blood analytes to look at your metabolism rather than using your height and weight, which is an inaccurate and very slowly adjustable parameter. With this, we can instantaneously assess energy states, and this is really critical as we come to understand how important energy is in health. A third one is we can use single cell analysis to assess your relative adaptive and innate immune responses in wellness and in disease very beautifully. And we did this in a 300-person, 2-year COVID study, and it gave us all sorts of new insights. And we're just finishing up a paper now on fragility, which is independent of age. So we can measure how fragile you are as you age. And it's very important for older people to know that and to avoid fragility and so forth. So those are all things that we can do. But the last thing I want to say that's really important, because it's all about the prevention, is in Airvale, we had 167 people that transitioned from wellness state to a chronic disease. 30 of them were in cancer, and we looked at 10 of those that transitioned to cancer and looked at the bloods that we drew, and we took them twice a year, prior to the diagnosis, and showed in 10 for 10 cases, multiple proteins had been elevated, and they often mapped into the very disease-perturbed networks characteristic of that kind of cancer. So we could do early detection. We could say which kind of cancer it is. And it gave us the tools to know which early simple networks were changed so we could modify them with drugs before you ever got the disease in the future. And that's one of the most important things the Million Person Project will do, because there we'll see more than 200,000 transitions and be able to map them out and try and reverse them to avoid chronic disease, which costs 85% of your $4.5 trillion cost in the US per year. So if we can avoid chronic diseases, we can affect enormously great savings. So with all of those insights, and that's what Phenome Health is starting to work with now, and we can go and talk about that. So I'll just ask, are there any questions you wanted to raise about what came out of Airvale?
Oh, thousands, but maybe I wanted to just kind of share with kind of an anecdote of my own, which will probably take us to a question where everything that you're describing is, effectively the driver that, kind of pulled me into molecular biology. So, you talked about your DNA, you talked about the environment, you talked about your behavior. But my mom got diagnosed with multiple sclerosis when I was around 14, 15. And she said, "Don't worry, it's not genetic." I wasn't so much concerned that I was going to get it. I was more concerned of how do I save mom, And back then there was no email. It was me writing letters to professors and reading books and finding solutions and learning that hey, there's a huge inflammatory response component here. You mentioned vitamin D. I want to come back to that one too. But there was that participatory component of it, right? Like we're not wanting to do these, proactive, you know, probably seemingly intuitive things. And that just was not the paradigm that she was living, and the habits weren't the things that she wanted to change. And so that, that really stuck with me for a time. And then I slipped to the other side, which is like the high performance side, right? Again, vitamin D actually being central in both instances here. So one thing that I would experience every year as an athlete, without fail, every year, some kind of injury, potentially career-ending injury, at least season loss injury, as we would approach into winter. Except this one winter where we did a training camp in San Diego, right? It's like, what's going on there? So that vitamin D challenge that you spoke about,
Yeah.
yeah, once I got onto that wagon, it was smooth sailing. But there were so many other things that I learned along the way, like my sensitivity to caffeine, for example, specific collagen markers that I was like more vulnerable to. And coming back to this whole participatory paradigm where like I was so convinced and compelled by this that I left my academic career as a professor at the time, Mount St. Vincent University in Halifax, Nova Scotia, Canada, and I first started to work with a performance. They were called performance genomics, but they were looking at reproductive longevity, and they had selectively bred mice for a decade, and they doubled reproductive lifespan. And my job was to figure out the multi-omics that would lead to such a thing. And that was my first experience in industry. And I never really looked through that lens. And then I said, hey, maybe I'll go a little further there. And that's when I started my own company, Athletigen, which took my two passions as a track and field athlete I mentioned, so athletics and genetics, and I combined them, and I set out, to deliver these insights to athletes to hopefully help them avoid injury. But, I was thinking because I wanted to know this, everybody else would too. And not necessarily. Like, so if you've never had an injury,
not necessarily true.
no. If you haven't had an injury, you don't really want to know, or you don't really care. But I'll tell you the one thing that I am seeing, and this just might be the bias that I have, is that when you talk about participatory, parents are very motivated to understand their, the molecular biology of their child. And I've been able to take these insights such that my whole genome sequence. My wife has her whole genome, our daughter, and so we can look at things like, well, your medications that we're certainly going to avoid. I can actually see some of the same tissue vulnerabilities in Brooke that I have. I can see the various nutritional requirements. And then it's now, how do I, turn this into, actionable operating system, such that, we plan our goals as a family, insofar as the habits and where we're going to be. But now the genome is part of the discussion and the dialogue. So I just wanted to share that, frame, with you, because I think that where I think this is so exciting, like what you're doing is you've talked about all these insights and all of these discoveries, essentially all these models, right? There's this like multi-modular future where like it's going to be just so cheap to get your multi-omic data, but the gap is going to be the speed at which we can, demonstrate the efficacy of the models, like what you're speaking about, and then how do we move them laterally across platforms rather than, our model is the best. It's like, no, there's all these like open source, publicly available models, and there's all these, kind of do it yourself organizations popping up, like, your Function Health and your superpowers. And it's like these, scientific wellness models are potentially available. And just talking to Sean Gibbons a couple of weeks ago, he was showing me some of the, the models that he's developed on the microbiomic side of things. And so I'm like, wow, that exactly lines up with about, 13 to 17 years where you see the implementation of the stuff that Ruth Lay and I were working on back in 2010. Now, Sean's got these predictive digital models where you can prescribe a diet, and so what I see with you is like that's 13 to 17 years is probably going to shrink down into 13 to 17 months. And I'll say, I'll just, one other caveat I'll just give you for context, because I really want to know what you think, is so when I did this Athletigen thing 10 years ago, it took me 18 months and $2 million to bring my product to market, and a whole lot of growth and maturity, because that was my like practical MBA, if you will. But now I look back and I'm like, well, gosh, you can now bring these commercial products to market in 18 weeks and under $200,000, and I don't have to invent the models because people like you putting these incredible models out there. And so do you see like a collaboration like never before between, academic research, industry research, and the responsible commercialization of these things? What's your sense in that regard?
My sense in that regard is until recently, no pharma was really interested in wellness and prevention. We're actually talking with a pharma now that is all the way into wellness and prevention for really good reasons. And it's thinking about collaborating with us to create populations that they can interrogate wellness drugs, and we can interrogate knowledge and deciphering complexity. And it's a win-win for both sides with the resources pharma has and can put into this kind of program. So I'm really optimistic that that relationship is going to end up benefiting enormously humankind. In regard to your own interests, let me just say one of the categories of actionable possibilities in the genome are those kind of self-genomic things. And there are 600 variants or so now that relate to athletic injuries in various ways. And that if you have serious ACL or groin injury kinds of things, you can do exercises largely to avoid them. I remember talking to Pete Carroll, who was then coach of the Seahawks, and some of the Seahawks football players about this. And I said, look, we could probably prevent a lot of ACL tears and and the players would have nothing to do with it. They didn't want the owner to know they had deficiencies, period. Even if we want to protect, they were fanatic about it. Whereas Pete Carroll was intrigued by the whole idea, but the players had the consent,
Yeah.
and how you teach them that in the end it would be really good for them. I mean, there are ways I think we can begin thinking about diagnosing traumatic brain injury and things like that. Athletes should be tested, football players and soccer players should be tested routinely on those things. I mean, just look at what it does to you in your 40s and 50s and 60s and your family, frankly. Yeah.
Yeah.
So,
Yeah. Yeah. I think I agree. I came up against that as well. Like the early adopters of what we were building for athletes, they were well, I mean, that just partially my bias because that was my sport, track and field. It was Olympic athletes, right? It was athletes who were not, frankly, were not under contract, but they wanted every bit, and their coaches wanted every bit of information possible because they were on the, the tip of the spear. And the coaches that they had, they weren't, involved in, or their agents, they weren't involved in negotiating these like kind of
yeah, yeah.
tens of $1 million contract. And I actually had agencies come to me and say, hey, look, once we get like the top 10 kind of rounds in the draft, we want to make a more informed decision. Can we use genetics because maybe there's some latent potential there that we can select based on that or deselect based on injury vulnerability. So people were thinking about it. And, on the one hand, I mean, there are so many things wrong with it. On the other hand, it's an interesting conversation that starts, right? Because, let's say for an example, like there's some athletes who they don't want to know that information for fear of, losing the contract. You have two athletes that are identical, and you have one that's vulnerable to an ACL tear and one that doesn't. It's like, well, okay, I'll take the non-vulnerable one, please. So, I think they're right in so far as the right to be concerned.
You can convince them, you can prevent them. That's the key.
Well, right. And I think the kind of athlete that's like, well, wait, I want to know. They're like, I don't know if you remember like the Nolan Ryan's the pitcher. He was always doing these fantastical types, warm up with the football. You got your Tom Brady, he's like the quantified athlete. And it's really, how do I know all of this information so that I might, leverage my talents, but also know the weaknesses so I can prehab instead of rehab. And I think that's why, coming back to the parent is a really nice spot because it's like, your parents and the young coaches, they really do have the best interest at heart. And so I think I told you on our last call, the personal goal where I'd like my daughter to have a PhD in her own body by the time she's 12. And I think that like for me, that's how I'm thinking about participatory. It's like in the home, and here's the vulnerability because my daughter is now looking at like gymnastics and swimming, and I want her to be kinesthetically aware. But that's just in the youth. As she develops through these different phases, goes through her own paradigms, how does this information become useful to her? So I wanted to come back to, the I think the other side of the commercialization that I was thinking about. And so, like you said, the 900 markers, it's like, oh, well, we should talk about those 900 markers, and I should update my algorithms, and how do we make that information more freely available? And like I said, there's all of these kind of consumer health products that are coming to market. Like I mentioned, like the Function Health and
Right.
there's like Superpower.
I'll tell you, actually, Jeremy, what we're doing is working with knowledge graphs and AI to put all of the tens of thousands of actionable possibilities into an AI that will be able to deliver them in a very simple way to physicians and to patients. And we're also working for a chatbot that into which I've put, for example, all the information there is about data-driven health, who can answer in very simple language any question you might ask about it. And these are going to be really enable coaches to.
Right. Yes.
I mean, my vision would be every family would have their own chatbot that would know about them. They could ask any questions. It would encourage them. It would be the mother that would nag them to do the essential kind of things. And for some people, there really are essential things they should do for their
Yes.
health.
Yeah.
But the big idea that I haven't discussed so far is this idea that really data-driven health is about two things. One, optimizing wellness, and that includes biological age, and two, preventing disease by detecting it early and so we can reverse it. And I think AI is absolutely going to be key for both of those things in giving physicians the ability to have domain expertise in all fields of medicine so that they'll be able to treat their patients in ways physicians never could treat their patients before, by being able to instantaneously respond to the AI's recommendation for this set of symptoms. But the physician would always check it out and be the ultimate master
Right.
of decision. But I think that in the fourth P, one of the absolutely critical kind of things is this idea we have to encourage physicians to partner in a really effective way, just exactly like Garry Kasparov did with chess. And the two together were unbeatable, right?
Right.
And I think physicians paired in this way are going to be incredible, whether it's family practitioners or the specialists. It gives them all the ability to view their patients in the broadest possible context of optimizing wellness and avoiding disease.
Amazing. I think I mentioned probably half an hour ago that there's a series that I can see unfolding here where I'd like to make sure that we come back on some really big questions that I want to digest before perhaps that time. But I did want to make sure that I got those three questions that I promised I would ask you at the beginning, and I wanted to make sure we left enough time because I feel like there are some pearls of wisdom coming here. And if you remember, those three questions were, simply, what if this was our last podcast, what is the key message that we want to get out to the world, and what one person above all others needs to hear it? That's number two. And then number three might be who would you recommend as my next guest?
Yeah. So do we want to talk about those now then?
Well, because here's the thing, I think we are going to run out of time if we don't answer those questions now. And then, I know that we actually have a meeting scheduled later again this week where I'm introducing you to Mike, remember the former chief architect of 23andMe. So I think if we could answer those three questions here, and we can then, set
We
up for
can
that
set
goal.
another program up. And I
Oh,
mean,
yeah.
you asked a lot of good questions we haven't even touched on.
I know. I wish I booked the whole day, and I think I will do that. You're in Seattle, right?
I am. Yeah.
Yeah, it might be worthwhile me taking a trip down, and if you're open to it, and just being a little more amenable to your schedule. But yeah, for today, why don't we finish with those three questions, and we can come up with a recurring meeting to get some of these big ideas out to the world.
That's fine with me if that
Wonderful.
makes you. So, okay. So then the first question is, if this were my last podcast, what kind of message would I like to get out? Okay.
Mhm.
So what I would say is, I'd like each person to understand that humans are really complex organisms and that big data and systems biology are necessary to interpret this individual complexity, and the analysis of your data with this approach will lead to optimizing to actionable possibilities that you can use to optimize your wellness and prevent disease. And the really important take home point is, look, you are the master of your health. it's up to you to educate yourself so you understand these things. But even more important, it's up to you to take advantage of opportunities like this to optimize your wellness and avoid disease and give yourself a health span that will extend out into your 90s or beyond, where you can be as active and productive as you were in your 50s. And I'll say for myself, I did 200 push-ups this morning.
Come on.
Biological age is 15 years less than my chronologic age, and I can do 25 flights of stairs without getting too winded. And I'm 87 years old, so I plan to be around for a long time to see data-driven health become a healthcare of wellness and prevention. And you can do the same. That's the message. But
Wow.
it takes a willingness to be that master and to make those decisions, that fourth P, that are going to make a difference to you. It really is up to you.
Wow. Amazing. And who would you recommend then as your nomination on the DNA of things?
Well, why don't I can give you 3 spectacular recommendations and you can decide which one you want to use. So Craig Mundy was number 2 at Microsoft for many years, and he's written a fascinating book about AI that gets into the humanistic issues of who's going to control whom and everything in a beautiful way. And Craig really argues that AI is going to absolutely transform the whole trajectory of human culture. I agree in part, but I think he's a little more enthusiastic about deciphering human complexity than I am, because in humans, the AI can only interpret the data you give it. What if you don't give it really important data that's relevant to you? Like, what if you never gave it any epigenetics and you didn't know you could modify the output of genes in that way and everything? You'd be missing something. And all I'm saying is we need many new types of data and new technologies to interrogate humans to essentially take this onion of complexity in humans and unravel many more layers of that complexity. So that's my simple message.
So that was your.
And so anyway, Craig Mundy would be one person.
Mhm.
I think a second is Roger Perlmutter, who is head of research both at Amgen and at Merck, and now has a new incredible approach to drug discovery in a company he's just started. And he's one of the most articulate, passionate people in pharma that I know. And the final person is one of the most perceptive people I've ever met, is Jeff Wilke, who was number 2 at Amazon for a long time from the beginning, and has now set up his own company to bring manufacturing to the US. And if you really want a fascinating topic, get Jeff in to talk about that. So I would say any one or all of those 3 would be spectacular for you.
Well, I'll do my best to track them down. And I love how it wasn't necessarily health as the theme, or DNA. I
No,
deliberately
best persons.
yeah, I deliberately call the DNA of things a little tongue in cheek, an ode to the nature of things with David Suzuki. He's a Canadian guy, but the DNA of things, it's like it's both on the nose insofar as that's my area of expertise, but it's also metaphorically,
Yeah.
like what is, and I actually I want to talk to you about this more at
Well,
length.
one more thing. Shall I answer the third one before we get off on that?
Yeah, sure.
Is who's the person I'd most like to meet?
Mhm.
I would love to meet Alice Walton, who has just started in Arkansas a new medical school dedicated to well-being and prevention. And
Mhm.
I really think the data-driven health that I'm talking about provides her with the essence of the kind of thing she should be teaching these students. And I would have programs for the students on AI, and AI is going to help med students in two ways. One, it'll help you learn much more easily, but two, it'll make you this domain expert in all fields of medicine that I talked about. And I think the second is systems biology. They know nothing about that. And the third, frankly, is data-driven health, population, individual health. Those are all key topics that don't get touched in medical schools today, for the most part.
Right.
Okay.
Right.
She's starting a medical school that could be a paradigm change in how medical schools do things. And I'd love to help her think about it in that way.
I'll definitely make sure that she gets this in front of her. And I'll share this one last personal thing with you. I'm advising my niece right now she's in her last year of high school, and she wants to go and become an obstetrician. Anyway, your ears were probably burning last Saturday when we were talking about systems biology. And, there's the school that you started in Seattle. Was that right?
Yeah.
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 Yeah. So I do. And I said, hey, you could in the next year know more about anybody who's in the current system now, insofar as having that paradigm of a framework, a jumping off point into your career, which I think what it does is I think it makes you more curious, because you see that I think to some extent there are these emergent properties that we can start to predict, but then there are others that are just so fascinating and surprising, and you're looking for ways to be surprised versus just want to know the answer to the test. So I think there's a different way of knowing that AI and systems thinking, I think, have in store for us. And I'm very excited that we're just kind of scratching the surface of this conversation. As I mentioned, I know we're
I'll tell
scheduled.
you the other point that
Yeah.
you made in your outline that was very good is what else can systems biology be applied to?
Mhm.
And I really think, and I'm not sure I want to talk about it in public thing. I think systems biology is the utter key for the Democrats to recovering the disastrous response they've had that could deal incredibly effective. And I'd be glad to talk to you off camera about that.
Yeah,
But
we should do
I
that.
think systems thinking could really change the world of politics in really important ways. And they don't even have most people don't even have a clue about that.
You know what? I did send you another invite because I thought this might happen. Do you want to it's in your calendar now for just a quick 15 minutes that we could close out the record? Do you want to meet there? I can hop over to that other meeting right now.
Yeah, I have till 11, so I could do that.
Yeah, why don't we just jump over there and we can be off the record and set up our next conversation.
Yeah, actually, I'd love to chat with you about that. Okay,
Okay. I'll see
we'll
you.
do it
See you.
again.
Yes. See you right away. Bye-bye.
Lee Hood left us with a simple, bracing challenge. The science is solved enough. The work is now persuasion and practice. So, three takeaways matter. First, think in systems. Health is an orchestra of interacting networks, not isolated instruments. Second, P4 medicine is implementable. Genomic and phenomic data yield real reversible signals long before disease manifests. Third, participation requires narrative and institutions that make prevention desirable and affordable. As mentioned, we recorded an off-camera deep dive that extends these ideas into political and economic design. Expect a short series unpacking that conversation and a printed companion piece in the episode 100 release. And we will map practical pilots, governance ideas, and community experiments that marry high tech with high touch. That is, coaches, clinicians, and citizens working together. Now, in this episode, if it left you curious, please stay tuned. And we look forward to the conversations to come and our co-creation with you, the listener. Thank you.